black. Okay, so you all have to take note of that. Okay, so I'm going to write down the things that you need to know. Okay, the process that you need to know. Okay, so what we're trying to find out here, we're going to find. Okay, before we say find, we're going to determine the diameter. Okay, we're going to determine allowable diameter of shaft. Right, that's what we're. So we are given that the shear stress allowable is equal to 50 times 10 to the power 6. Is it times 10 to the power 6? Yeah, Pascal. Right, that we're given. And we know the formula that we're going to apply is tau max is equal to C over J square root of, so if you look at this case, so if that's our X, this is our Y, and there's our Z. We know that we're having moment in Y squared plus by moment in Z squared plus by torque in X squared. Okay, and as I said, we know that there's no what? There's no zero axial load is applied on the shaft. We know that. Okay, so only when we know that, then we can apply this. Okay, so this is zero axial force and shearing stresses generated by the shear force or shear forces. Okay, so shear forces for this case, they are both in the Y and Z direction. Ignore. Okay. So now we have to find. So this is our task. Okay. So we have to find. Okay, find. Right. As I say, the formula is easy. Right. The formula is real straightforward, not difficult at all. But now we have to find our my, mz, and our what? dx. Okay. Now we have to find this. Okay. So now I'm going to write out a set of procedure. Okay. That I want you all to remember. Okay, so this set of procedure, you have to or when you're analyzing a shaft, you just follow this procedure. And I've used this procedure countless amount of time. It always works. Okay, so why not share it? Okay, so the first thing is, okay, so solution procedure. Okay, is you have to determine, number one, determine the rotation. Okay, they determine the rotation of the input gear. Input or the driver, okay, gear. Okay. So for our diagram over here, right? So I'm going to paste, I'm going to copy. So for our problem, you see, they did not tell. Oh, they did tell you. Okay, they did tell you. Okay, so this direction over here, right? As you can see now, yeah, you can see. So this is the driver gear. Direction. Right? If it's not given, you decide. Okay, if you want clockwise to be the driver direction, you decide. You want anti-clockwise, you decide. Okay. So once you get that, okay, the next thing you're gonna do is focus on the contact points or between the adjacent gears. Like what I told you, I highlight earlier. So these are the point of interest. Okay, so this is at the top, and this is by the side. Okay. Then the next part, the third part, is you determine the applied force right? You determine the applied force okay, at the contact points for the driver or the input gear. Okay, my apologies. You know what I'll do? I'll write driver down here, and this will be input. Okay, right? Then the fourth thing that you have to remember is you have to determine the direction or the force direction of the driven, not driver, yeah? Now it's N. Driven output gear. Okay. And the force, okay, the force is controlled okay, is controlled by the input gear or by the driver gear. I'll put input down later, okay? Okay. So the output gear direction, okay, the output gear direction gear force, okay, force direction will always right will always oppose the input gear or the driver gear direction. Okay, the top part of the sentence I have to move it because I forgot to put in the term driven. Okay, and I'm gonna show this. Okay, I'm gonna show this. So if you look at, I'm gonna copy and paste another diagram. This is from the textbook. Okay. Okay, so these are the forces from the textbook. Okay, these are the, as I say, these are the forces from the textbook. And we are going to prove it. Okay, so I mean, this is from the solution manual. What if you don't have this? Okay, what if now you don't have this? Okay, what are you going to do? Right? So that is what I'm going to teach you. What are we going to do? Okay. Okay, what are we going? Let's say you're without that. What are you going to do? Okay. So let's prove the force direction. Let's use what I've taught you. Right. Let's use what I've taught you. Right. Into this. Right. And then we go from there. Right. So I'm going to draw. I'm not going to draw 3D diagrams. Okay. I'm just going to draw 2D diagrams. Okay. All right. We can draw 3D. Let's draw 3. So if we have our, so we have 3. Okay. So we have our 3 gears. One. This one of our gear. Okay. As engineers, we need to know how to sketch. I'm not very good in sketching. Okay. So this is our gear E. Gear E. Okay, so I'll copy. I'll show you what diagram I'm referring to. Not this one. This one. Okay, so you can follow what I'm trying to draw. Right. So there's gear E. Then we have our gear D. Okay, so there's our gear D. Then we have our gear. So this is our gear D. And then the last one is our gear C. Okay, so there's our gear C. So gear C is smaller. And all of them are attached to a shaft. Okay. So this is our gear C. So gear E is our driver. These are our driven. These are output. Sorry, I better standardize. So this is our driver, driven, and driven. Okay. So based on the rotation of our motor, we know where the contact. I highlight this. Okay, where the contact point. So let me draw transformation also. So this is our X, Y, and Z. So the motor is contact. Okay, so if I were to draw a chain line over here, it's in contact over here, right? and it's inducing a force downwards.